Hello everyone. So, today we are going to start exercise number 10.2 from the chapter 10 circle. Okay, so let us start. Question number 1, that is, all sum are on the base to prove something. Okay, so be careful when you are writing the argument. Okay, so first question, recall that two circles are congruent. Two circles are congruent if they have the same radii. Prove that equal chord of congruent circle subtend equal angle at the centers. So the question is that the circle are congruent. Okay, the circle are congruent means they are equal in size or they have equal radius. Okay, if the radius of the both circle will be equal, they will become congruent automatically. Okay, so indirectly it is given that the radius is equal. Okay, it means that two circles are congruent. Now in that circle, what we have done, you see, we have made two equal arcs at two equal chords, whatever you say. If AB and CD are equal, it means if the length of AB and CD are equal, then what will happen? The angle subtended by that chord means angle AOB and angle CO'D must be equal. That we have to prove. So for that, what we will do? We will prove that this both triangle are congruent. Then if the triangle are congruent, the corresponding angle and the corresponding sides will be equal. So let us see, first of all, the name of the circle is not given, the name of the chord is also not given. So we have to first define everything. The first circle with center O, the second circle with center O dash, because nothing is given in the question. Only the statement is given. So first of all, we have to tell that two circles with center O and O dash are congruent. Okay, we have drawn two circles. Okay, we have drawn two circles with the center O and O dash, and already it is given in the question that these circles are congruent. Okay, AB and the CD are equal chords of the congruent circle. So AB and CD are equal in the length. Okay, now see, in a triangle AOB and COD, I think CO dash must be there because the center of the second circle is known as CO dash. Okay, so the triangle name will be CO dash D because the first center is O and the second is O dash. Now you can see AO will be equal to CO. Why? Because it is the radius of the circle and it is already given in the argument that both have equal radii. So AO and CO are the radius of the circle. So I think there is small mistake here. Dash must be there. OCO dash DO dash, because the name of the center of the second circle is O dash. So AO is equal to CO dash, then BO is equal to DO dash because it is also a radius. Now AB is equal to CD because the chord are equal in the length, it is also given. So now if two triangles have three equal sides, so we can apply the SSS criteria for congruence. So SSS criteria for congruence, by using that argument or using that relation or using that formalism, we can say that triangle AOB congruent. See, this sign is used for congruence. Okay, equal to sign and small arrow, that's on the, not arrow but small sign on the equal to, it will known as congruent sign. So triangle AOB congruent to triangle COD. What it means? Congruent means each and every side, corresponding sides and corresponding angles to both triangle are equal. Means the length of the sides and the value of the angle on the both triangle are exactly same, then you can write it is a congruent triangle. Okay, it is clear? Okay, right now. So if they are congruent, we can write, what we can write, angle AOB is equal to angle COD by using specificity rule. Okay, so that is very easy. When you are not able to prove directly that angle are equal, okay, so you can prove in this manner also. And one more thing, that we can use also that another argument, equal sides have equal opposite angle to it. If AB and CD are equal in the triangle, so we have already one theorem, that if the length of AB and CD are equal, okay, it means that the opposite angle to the sides are also equal. Okay, that theorem can also be used here. Now the next question is that prove that if chords of congruent circle subtends equal angles at their centers, if chords of congruent circles subtend equal angle at their centers, then the chords are equal. Now this you can say inverse theorem of the first one, or inverse statement, not the exactly theorem. So first, in the first question, what we have done? In the first question, we have proved that equal chords makes an equal angle to the center. Now the inverse statement that is given, if the angle subtended by the chord at the center, means this angle, see in the figure, this angle and this angle are equal. If these angles are equal, then the length of chord AB and CD will be equal. Okay, so for that we will use the same method that we have used in the previous question. What is the method? We have proven that the both triangles are congruent. Okay, so if we can use that method here, okay, we can say that AB is equal to CD. So now we have to give the name. So two circles with center O and O dash are congruent. You have to draw these circles in the answer. Okay. Now AB and CD are the chords. See, AB is a chord and CD is a chord. Now first argument will be there. What is our first argument? Angle AOB is equal to angle CO dash D. Okay, because it is given the angles subtended by the chord to the center are equal. It is given. So we will prove that this both triangle are congruent. Okay, so in triangle AOB and triangle COD, imagine here or see here, AOB and CO dash B, what is the same in between these two triangles? So the same things are AO equal to CO dash because it is a radius, BO equal to DO dash, and AOB is equal to angle COD because the angle subtended to the center by the chords are equal. It is given. So now by using SAS criteria for congruence. What is SAS criteria? SAS criteria means side angle side. If two triangles have two equal side and one equal angle, then another side and another two angle will automatically becomes equal. You try to draw at home, make a two triangle of any measurement, whatever you like. But you should keep in mind in both triangle, two sides must be equal and one angle should be equal. Then you will see that another two angle and another one side will automatically become equal. So that's why it is known as SAS criteria for congruence. So if we use this criteria, we can say that triangle AOB is congruent to COD, and that's why each and every side and each and every angle of the both triangle are equal. So by using CPCT theorem or CPCT rule, not exactly, so AB equal to CD. That's how we have proved this given statement. Okay, mathematics is a subject of reasoning. You have given an statement and you have to prove. That is the original mathematics. Okay, not only we are calculator. Okay, we are not calculator. The argument and reasoning must be there. That is the main point of the subject of the mathematics. Okay, we can do calculation by using machines. Machines are for calculation, but they have not the power of thinking. Okay, humans have the power of thinking. They can think, they can write a logical argument. Machine works on the instructions. Okay, our calculation must be fast, but we cannot do calculation faster than machines. But we can use our logic to do something new. Okay, now question number 3. Prove that a line passing through the midpoint of two parallel chords is also passing through the center of the circle. Okay, I am just explaining figure right now for this one. Okay, you have to write some arguments. So see, what is the statement? Statement is that if you draw a circle and two parallel chords, okay, two parallel chords, and if the line is passing through midpoint of this both chord, okay, if the line is passing through the midpoint of the both chord, okay, so it will automatically pass through the center of the circle. That we have to prove. It is very easy. Okay, you try. If you are not getting, okay, send a message. I will give you proper response. Now next question is that, okay, this E1 E2 are the extra question. Okay, now the next question, two equal chords AB and CD of a circle with center P intersect at point O such that P lies in the interior of angle AOC. Prove that angle AOP is equal to angle COP. Now, what is the question? Understand it carefully. Question is that two equal chords means this is the circle with the center P. Okay, circle with center P. Two equal chords means this is the first chord, and I think we should draw second chord here. This is second chord. What is the name of the chord? A, B, and CD. A, B, and CD. Now see, intersect at point O. So now we have to change our figure because the two chords are intersecting to each other like this. Okay, so we are writing CD here. Now this is O, point of intersection is point O. So prove that angle AOP means angle AOP is equal to angle COP means angle COP. Okay, is it visible to everyone? We have to prove that angle AOP is equal to angle COP. Now this will be also proved by using the same manner. You try. Okay, so these two questions just you have to try by yourself. Okay, so today we stop here. Thank you very much. Jai Hind.